markers that you already know the fragments, how will they separate. And as you said, with the loading dye, we can locate it, we can quantify it also according to, as you said, the activity of the dyes. Now, the separation between, as you mentioned, there's pores in those metals, which will enable these fragments to migrate to the positive side of the chart, according to the antigen size. So they stop according to that size, and they'll be identified. You can identify and visualize the fragment of interest.
Also, the DNA of the RNA, we have something called the molecular weight. So the molecular weight of the DNA of RNA is larger, means it will move not further from the cell. But if it's of low molecular weight or small size, it will move to the farthest cell. That will help in separating. So as the DNA moves, it will bind with the dye. The dye will use this measured lithium bromide, but it is carcinogenic, so now it's not being used. You can use gel red for that part of it. So when it moves, it will pick up the dye, and that when the UV light from the visualizer hits the dye, it will reflect the band side.
Anyone with a different opinion?
I think
They have to
from the lunch you're taking, I think the energy.
It's working.
It's working. You don't have to add it.
It's a pretty good answer.
But he did a good job.
Yeah. So the both of you
should have raised his hand.
the both of you see me as a no, like when you are done, please remind me I have this thing. And then you mentioned that you talked about a dye.
Yes.
You also talked about a dye. So we have so many dyes. We have. So what's the difference of the dye you talked about? So there's a DNA stain and there's a loading dye.
Yes.
Is it the same thing?
They are two different things.
Are they different?
The difference is we have a loading dye that we use first, and we also have the intercalating dye. So the intercalating dye is the one you put on after you warm your gel until it has dissolved, is when you put your intercalating dye.
So what is an intercalating dye?
An intercalating dye is a dye that when it comes into contact with your DNA and UV light is shone upon it, it will enable you to visualize your bands under the transilluminator. Yeah, the machine that you use to see, since it allows you with your eyes, the bands. You have to use that machine to aid you. And then the loading dye is to help. The loading dye has got its advantages, which is first you mix it with your samples so that they will sync on the wells. And it also helps you to visualize where you've already placed your samples. So, yeah.
Any comment on that?
Maybe I did not get it clear. If I put it on my own way of explaining, the loading dye, I put it with the gel, and I mix it, I homogenize it with the gel before it solidifies. So that under the UV, you will locate. And the undercurrent dye, you will mix it with your sample. So something is for the sample, something is for the gel itself. Yes.
It's the other way around.
No.
The loading dye is the one you mix with the sample.
Yeah, the loading
Yes,
dye.
you mix loading dye with the sample. Intercalating dye, there are some you can put them in the gel itself, like lithium bromide. Cyber green, you mix it with the DNA. Yes, I don't know about gel red. I've never used gel red. Yeah, I've used cyber green and ethereal. That's what I know.
Do you agree?
No. As I define intercurrent, it will
Intercalating.
Intercalate. I studied these things in French. So it will intercalate between the amino acids, if you are doing proteins, or between the bases of the nucleic acid. That's why it's called intercurrent. So you mix it with your sample.
So basically, for both of them, you can mix with a sample. Different functions though. The loading dye does not raise the basically for guiding you and where you're blessing your DNA. So it's basically a guide to show you if. So you remember the wells on the gel are very tiny. So for example, with the standard kits, you will not be able to inject them to the level that it should be. So the loading dye is normally colored, either purple, blue, basically to guide you. The intercalating stain or the DNA stain doesn't need a color. Okay. So the cyber green, when we talk of cyber green, when we talk of gel red, it's about the fluorescence, like they are more fluorescent. Yeah. So they intercalate, and then once integrated in the DNA and put on a UV light, you'll be able to visualize them.
So question,
Back
so
to
how does it intercalate the DNA? Does it bind to a specific region of the DNA? Or, like I know for sequencing, it terminates, the fluorescence terminates on the sequences. How does the medium of gel red intercalate the sequences, the DNA sequences?
I think the structure of DNA and the way it could bind. I don't know if it is the phosphorus.
No, I think she had partially answered.
Yes.
Yeah, because we have some dyes that you can just prepare gel without putting a dye, then you mask the gel in the dye
Yeah.
afterwards, after running the gel.
So remember also, like the intercalating dyes, basically even if you have to put them on the gel, there's no DNA on the gel. We are assuming that your gel is, remember you microwave it, like we are assuming it's clean. So when the DNA moves around, it will pick up the stain. It will, like, that's why you would, if you visualize it, you will not. But anyway, yeah. First answer, how does it intercalate? She answered partially.
She can answer them fully.
Okay. The answer I will give, it will stay partial because it has been like 6 years since I studied this thing. Okay, it will intercalate between the bases. There are some bases that will form the bases there will be some charges between the two components. There are some that, if you take for example the DNA, we know that if it's double stranded, it will fix in the small group, and I think it will fix in the small group, not in the big group. And then there's others that will form ionic charges with the bases. I don't have a full picture, but at least the concept of.
Waiting for your answer.
There was another issue of the factors that affect the movement. And you mentioned something about the weight. What else?
I think the size of the gel, percentage of your gel preparation.
Bianca, contribute to something. What else?
So what's the conducive percentage for PCI? Like for our case now?
PCR products.
Yes.
So we'll do a 1%. Do a 1% gel. Should be able to see the 60 minutes.
1%.
1%. Why are you not asking questions? I need more questions like Isaac is asking. Like for example, how did we get to the 1%? Why are we doing 1%? Because we are not asking. Why are we doing 1%?
1%, because PCR products are of smaller fragments, so they can easily pass through dense agarose. Because 1% is considered a bit dense, as compared if you are doing genomic DNA, you do something like 0.8%. So if you do 1%, it's like you're increasing the concentration of your gel, and since PCR products are smaller fragments, they can easily pass through there.
But then all PCR products of the same size?
No.
So what is the standard size for? He said we are working with 16
I'm not quite sure, because there are some 16s we also use 1.2.
But on average, yeah, on average 16s. What is the standard size of that 16s region? Let's say,
the size,
yeah.
like 1500 base pairs. You mean that? Or?
Yeah, so, okay, yeah. And genomic DNA normally
It goes to
from,
KB.
okay.
Yes, like it's bigger.
Okay, so you've been working with high molecular weight genomic DNA.
Yes.
Now that's what we look for when we're working with PacBio system. Ideally, the input for PacBio library, we prefer to have 15 to 25 KB. With standard kits, you will get less than that. With the standard market, with the standard kits in the market, you'll get smaller fragments. But then for PacBio, high fidelity, long read, we require 15 to 25. If longer, even better.
So does it mean that for PacBio you can't use PCR products?
No.
You just use genomic DNA only?
Yes. So for PacBio, so remember we have two platforms for PacBio. We have the short read sequencer and we have the long read sequencer. For the short read sequencer, you do PC, like it's basically a short read sequencer. So you can amplify, then you can work with fragments. But with the long read sequencer, the input for the library, you need between 15 and 25 KB long fragments. You will not get those from PCR.
Yes.
So ideally, you extract what we call high molecular weight DNA. That will give you like basically those 15 to 25 KB long fragments. Once you have those, then you go directly to library preparation. But then before you go to library preparation, you do what we call sizing. You have to size to be sure that you have such long fragments for it to work on PacBio.
What do you use for sizing?
There are systems which have been validated for that. One system is called the Megaraptor. Megaraptor. Like there are machines for that, for sizing. Yeah.
So you put your DNA there and then
it's basically it's a separate machine, like for sizing.
Mm-hmm.
Like the same way you have your qubit,
mm-hmm.
but now that's for like longer fragments. You know, I think for the qubit it does up to, I think 10,000, but for this one you're looking at 15,000 to 25,000. Yeah, so you're looking at longer fragments.
Yeah, the question was, how do you know that the sample is of high molecular weight or low molecular weight?
So you size it.
You size it.
Yeah. But so one way of, like, before you size it, you cannot use gel extraction method and expect to have a long fragment here. So you have to use a method of extraction where at least it has been validated to produce, like to give you long fragments. And then once you are done, you can size it.
So what do you mean by sizing?
So it's basically quantifying, loosely talking, it's quantifying, but there is a system which has been validated for sizing. Yeah.
So
I'm not sure which. I would need to go back and check. I'm not sure which technology it uses. If it does, I'm not sure. Do you remember? I'm not sure of the technology it uses. But then, yeah, I will need to check back on that. Yeah.
And
So, let's welcome. I think most of you have met Riva.
Yeah.
We have our managing director, Mr. William Nyakundi, with us. So they know all these things that I'm saying better than you. So you can ask them that questions. But yeah, so basically, the exact size is important. Yeah.
So, for example, you want to do short trees, you have to remove them.
Yeah, so if you did a high, so first of all, high molecular weight extraction kits, yes, they are big pricey. See, like that's, I would say that's a special item. So they are big expensive. So it makes logic why you get a high molecular weight kit for short trees. But assuming you have and you have high molecular weight DNA, for you to do short trees sequencing, you have to fragment it, yes. Because even with the standard kits, remember, fragment DNA for short trees sequencing. Short trees sequencing, you have bases of 150 to 120, get a sample.
So for short trees, I believe short trees, you have introduced short trees in the recent, year or so.
Yeah.
Do you think you are better than Illumina, or you're going to be better than Illumina?
So,
And would you?
The answer is biased.
no, the answer is not biased. So, define better, because we are already better. Not about anything. So, see, what aspect are you looking at? If you are looking at data output, so first of all, PacBio has a totally different chemistry compared to Illumina. This chemistry is giving data in the quality of Q40 plus. Most of the current platforms, I'm not saying the brands, but they have not achieved Q40. PacBio has data validated, going to Q50 now, with papers already published. So yeah.
No, but my question is, does that work? Because I know about it in terms of long reads. Is the case the same for short reads? Like, is your accuracy top notch?
So
in terms of
the accuracy of the PacBio console, which is the PacBio short sequencer, is higher than that of the long read sequencer.
So you're telling me your short reads are good?
Yeah. So in terms of quality, the quality of next generation sequencing data is measured in those Q40 values. So I'm telling you that the console is going to Q50. It's more than 95%. So during the presentation yesterday, no, it was not mentioned, but in a recent paper, I think it was 95% of the data was more than Q40. 95% of the data. While in the current other systems, we are talking about Q90. So that answers the question. In terms of
comment on salt.
no,
You are
in the other case, like in terms of the sequencing reagents, because of the sequencing technology, you need less reagents. You don't need to do the test of the current platform. What I tell you, you have to do 30 times, more than 30 times. You can achieve the same quality of data with 20 times or even less. That means you're saving on time, you're saving on IT infrastructure, you're saving on data. So, you also have to
So maybe it's good to see you guys here, and in the next welcome even after this training, you can come visit us. When you go back to where you're coming from, market our services. As you've seen, we now have functioning service level. So when you go back, market us there, and feel free to visit us anytime. So I'm going to allow Riva to say around. She's been working today, so that we can release her to be on the
Thank you so much for saying that. I'm really interested in this very bright yellow lab coat that you're wearing. And I'm research, yes. You can't miss the yellow lab coat. So I am the product specialist for Zymer Research, as you heard in my presentation yesterday. So I'm your assist with any
Just anything that you would need, if you want any advice or any assistance in your lab. We can do it virtually, we can send a cover team in person to come and assist you. Um, and yeah, they will still do the quoting and stuff because they are the distributor for Zymo Research, but I look after the entire Africa region. So I'm based in South Africa, in Cape Town, but we work virtually with these guys and with our team in West Africa, and then together we cover the entire of the Africa region, basically through Zymo Research, and Incova is the sole distributor for them. And I'm not sure if any of you have used the kits before, but I'm sure you can agree that they are very easy to use, they're affordable, most of them are in stock, right? So a very well-known brand. Yeah. So if you have any questions regarding data or RNA extractions, then you're more than welcome to ask.
Well, my name is Isaac Jackie. I'm a PhD student. Well, I've just noted that Brian is a teacher, but you can also post to come along and carry the research. Something that I didn't know that was inside the facility. So,
Yeah, that's good. And we post it on social media, just as a bit of a marketing, just to show if you get.
Yeah, when the gel is
You prepare one or use one that I have in stock, gel.
gel.
Yeah,
The one
because
that
it
you
will take
have.
like 30 minutes
The one
to
that you have.
solidify. Because it will take
Yeah,
like
it
30
will
minutes
take
to
a couple of,
solidify.
yeah, just bring yours with load.
Yeah.
Yes.
That you can explain the process
I will.
for me to learn.
So in the meeting, you can talk about those key ones.
Okay, let me start with reverse and forward. So we know that DNA is double stranded, right? So two chains of DNA reverse and forward, we know that the DNA runs from 5 prime to 3 prime, and combination with the bonds from 3 prime to 5 prime. So when we take the first chain that is running from 5 prime to 3 prime, that's when we call it forward. Now the inverse of 5 prime 3 prime is 3 prime 5 prime. It's just reverse. So if I take a gene I take it from the first nucleic acid to the last nucleic acid. I take it. It has 2 chains because the DNA is double-stranded. Also 5 prime 3 prime is forward, and the second one is the reverse. So now when we have done the amplification with a PCR, we have given 2 primers, a primer for the forward and a primer for the reverse. So this one will limit the gene from this side, and this one will limit the gene from this side. And the 2 chains are amplified. When the gene has finished, because now you locked it from both sides, that's how you locked a gene with its own 2 primers from both sides. That's how the enzyme will know that the gene is amplified. It stops. It will go to the other two chains of that same gene selectively by the primers. That's why we call forward and reverse. Regarding the short reads and the long reads, I think the best one to talk about it is right, but basically it's the length of the amplifier. So if the machine is able to read a whole genome at a go, that's a long read. If you are doing a targeted gene sequencing or strand sequencing or something like that, that's a short read. It depends on the number of the bases. But again, I think Mr. Brian is the best to give more details.
What could be the meaning of targeted sequence?
Yeah. We have, in everything, we have something targeted and something untargeted. When you go to metabolomics, you will do targeted, you will do untargeted. If I get a plant and I want to characterize it targeted or targetedly, so I tell the lab technician, please analyze my polyphenols. So I'm doing targeted. I want to quantify my polyphenols.
So I think we can move to
Very beautiful.
next.
Just pause there.
To be continued.
Okay. So to prepare 1% agarose, you weigh 1 gram agarose. Then you prepare. So I want to prepare TAE. We have TAE buffer. We normally use TAE 50x, 50x TAE for running our gels in this preparation of the Gaga. So we normally do 40 in 2 liters. So I'll do 1 liter today. So that's 20 in 20 in 1 liter.
Yeah.
Okay. So that's how I prepared my gel. So of course you have to boil it using a microwave until the solution is clear. Then you cast it on a plate like this. So once you cast it,
You have these rubbers on first. So you cast your gel this way. And you put your combs, gel combs, depending on how many wells you need, you will arrange your combs there. So for preparation of TAE, we normally use, deionized water. So can someone tell me why we use deionized water instead of distilled water or something else?
Because it has no ions that would interfere with the. Yeah.
So basically, we want to ionize the water with our electrolytes. Do that. Electrophoresis. So we add.
You just add, you don't measure?
So,
It's already there.
I'm
It's
just
measured.
topping up.
That's the.
I'm
Yeah.
just topping up.
Is the deionized water in Cabal produced?
No, no.
You don't buy it from Incaba.
Unfortunately, that
thing cannot be commercialized by Incaba.
How do you get your deionized water?
But
So
we
we
sell-
buy it. We have to buy it from.
but we
Oh.
sell it to, we sell it.
Oh,
We
okay.
sell it. Can you willing to wait?
Too much.
Does Incaba need something to
Does Incaba not sell anything?
It's too much, but I
Please.
use it for.
Yeah, you sell it water.
That will be 1x TAE now if you make
Yeah,
that.
it should be 1x.
Yes.
So remember we had 50x.
50x.
So this is how we buy it, 50 in stock.
We make it in
So
our
we bring
JPAC
it down
labs.
to
50x.
we mix trees and EDTA,
Yes.
Yeah, we make it
50x
from scratch.
from scratch.
We also,
Yeah.
we also sell the trees, the EDG,
Add this Incaba.
Wow.
Yeah.
and we also sell it to you. Done.
Please, don't be selling tomorrow drinking water.
To the Gen Z.
Oh wow. Which I don't get the concept of why do we have to watch something
You, Incaba, the big one, why aren't you producing? You are talking about us, the students who doesn't have 200 Kenyan shilling to go to Juja. And you are big Incaba, you are complaining about this. Do it.
Yeah, well, we'll get them.
They will get, you just have to get the deionized, right?
You get water from the mountain, you process it for free.
She was today that he come tomorrow. Our sister from Kisumu. Saying that tomorrow we come.
Who said that? Why are you lying?
If there is no strike, you come.
The problem if we come, we might be stuck here.
Yeah, that's the thing.
In the morning it will be okay
In
to
the morning you can
then
come,
it
and
will
then
be
when the evening gets.
Going in the evening, you are stuck here. They'll offer for us mattresses.
Where?
They'll have to.
Incaba are like a model, they'll be a model house. The same way they are model lab.
You want to sleep on top of the
We'll
machine.
sleep on top of the
And
machine.
drinking water, please.
Don't have paraffin. Just check. Is it the fever? Is it?
How do you know it's enough?
So you check for the fill line. There's a maximum.
Oh, yeah.
Can I say I know it's enough when I put the nari and it's
Yeah,
submerged inside? That's how I usually know it's enough.
Yeah, so some people use that, but I normally just follow the fill line. But also consider the gel. Once you put it in,
Yeah, yeah.
yeah, so I normally store my gels. If let's say you have a busy week, so you just prepare many gels and keep them. You just store them in the same at 4 degrees and forever.
The same buffer.
Yeah.
The same
Okay.
stay forever. Yeah.
Oh.
So
You stay them at what temperature?
at 4 degrees.
4 degrees.
You can stay forever. So you don't have to prepare gels every time you. Just align it. Make sure the wells are facing up.
And the wells are the negative.
Yes, yes, the negative side. We also want to prevent any
Water.
water on the
So why are the wells on the negative side?
Because it will migrate from the negative,
Negative
to
to
the
positive.
side.
DNA is negatively charged.
Incubus graduates. Incubus graduates, you can answer. We must be given scholarship in UK now.
Yeah, in South Africa.
Unfortunately, South Africa is the most we can do.
It's fine. It's fine.
to South
It's
Africa.
fine. Please send us.
Like right now, I'm telling you not to put me in a suitcase.
Argument about the.
But if
You can
we
extend.
could have come to Kesho, then we didn't have you would have come
Yeah,
on
Friday. Yeah. Okay, Friday it is.
So instead of Ethereum, we normally use the safety.
So you guys were out here mentioning cyber green, gel red.
I have ever heard of Safety, but I've not used it.
We do supply the safe view, which is not carcinogenic.
Which is safe from the name
Yeah, it's
Safety.
very safe.
I figured.
The person who had sent you here today,
He knew what he was doing.
he knew.
So these ones just daily see the wells.
So it's like, we don't, it's not a component of the gel or something.
Yeah, it's okay.
So it's not a component of the gel or something.
No, it's just a
Just the paper.
daily
We missed that. We missed that. The white team.
You're the one who brought us up. We start with the yellow tea.
They're not giving me the fine.
make sure it is under it.
You just make sure it's under the well so that you can see the but also you can use this sample. So remember our master mix was had a dye, so we don't need to use.
You're the one saying that contain corrosive. I mean, that one is preferred. Like this one.
What do you mean? This one is already optimized with a dye.
With a dye.
Fine.
So you don't need to put a loading dye.
You don't need to purchase another dye from
But this is different from that. That is
No, the intercalating.
yeah.
Should be this one.
Intercalating is safe. It is safe.
But some master mixes do not have the
So you can
integrated
or dye.
And what are these other two?
So
The
this
ladder,
is
loading dye.
loading dye. So we'll use it for this ladder because it's clear.
Oh, you use it for the ladder only.
Yeah. But the rest of the samples.
Okay.
Yeah, 1 and 2. Yeah. May I ask, the loading
So the ruler is
Yeah.
the ladder. The unit of the ladder is 1 kg. Can you get 1 kg?
It doesn't have already dyed.
No.
There's an option. There's a quick load option which is already preloaded. Then there's this option too. So whichever one you like.
Exclusively in Inca.
It covers all the options. All options.
Marketing now.
Yeah, so I think I'll have a few of you do the loading. Okay. You can use this to load your dye, your gel, your lacquer.
Something, by the way, you see, when I see sometimes students laughing and doing saliva, sometimes into the dye. You know the effect it has, isn't it?
What?
Sometimes when you're, yeah.
You think with that?
Well, you see, when you just came here, there are some aerosols.
Getting it there.
They might sometimes appear in the profile.
I don't really think so, because they don't have intercalating dye. They won't appear.
Are you saying that they cannot be some?
I don't think so.
With gel, you can get some of the profiles
What appears in your gel
from your saliva.
that is not there, that is just
So you
it's
load,
usually inside that gel itself. When you have
load
put where you have put your intercalating dye, that's where it appears. Yes. But it won't appear because you're there and then you close down. In the gel. The thing is, they won't affect how you.
You don't need it to be sterile.
Exactly, we don't need it to be sterile.
No, we are just going to quantify if you want to do the concentration. But at the end of the day, you are going to discuss this. It's not something you are going to use it in further steps of your project.
I wanted to promote that kind of, mistakes, you see? I just know you don't really. People are going on fire because of.
Saliva droplets.
Oh my. Can you exactly?
So you already have it. If you look at the gel, you can see it's already.
put the loading there to
So for the samples, you don't need to put the loading there.
you just need to load it.
Just load it with the ladder.
Or with the ladder. But the ladder is the
So remember our samples have already died.
yeah.
Yes, you don't need to use them.
Brand is this and one. This is
So these are basic, the base,
Basis.
just the DNA, the ABCGs.
1500.
The question is, how do you choose your ladders? Why are you using a 150 ladder, not a 1 kg? 50 kg.
You already have a figure about your project or about what you are doing. If you're doing like a big fragment size, you go to a bigger ladder. But if you know that the fragment that you are interested in is probably 60 baseline, you go a marker around 100 only or something like that. So you have something in your mind according to your project. What are you running? What are you doing?
What is your amplicon size?
Do you have the whole genome here? Go
That's a
for
famous
KT.
question in seminars. What's your amplicon size?
So you already have a picture in your mind. What are you doing?
I think I should take a small bit of the record
We just need a dot.
yeah, but then I will see the file.
They have like a chart that helps you see
Just
where
just
yeah. So if it gets to here, you know this is
Is one enough?
That's it.
Right. So this is one enough for the loading and then I
for this ladder.
this one.
One enough
For loading that so that I can mix the two point five.
And remember, you don't really measure the loading rate. You just want you just need a drop. A drop of it. Just to stay in the
Some markers not with colors. You find red, green, according to the density. Like the one for solar panel, you find it yellow at the beginning.
It's called Solis. The one
Solis.
is strongest.
Some is very dark.
Yes, very bright. Solis very bright, yeah. I told you it was S.
So I find it like this one is in red. Then there is another one with that one is solar panel.
Estonians are known to produce very good.
Solar is biodimensional.
Yeah.
And
Think about it.
Inca is the best. Come on, say something. She was almost dying here. What are you saying? By the way, this one's also nice.
but expensive.
Yeah.
Solar is biodimensional. Actually, 150 reaction.
Doing what is the Australian?
They usually come with a loading rate. So you also need to work fast because some of the reagents you need to install them immediately after using.
And this
I know your backup for your lab, Brian, in case of power outage.
Yeah, we do have a UPS.
Yeah, it's the model lab of Incaba. Guys,
They should put you in marketing now. Yeah.
it's like we're not promoting it.
Oh,
Okay.
what's happening? It's okay, it's okay.
You've made it double.
I've only put the
Ladder.
ladder.
Okay.
So somebody else can also put the sample one and the So inaonyesha official wala shida. So ili this kidogo ili niweze kuwa kujadili na mimi kwa value. So that I can put this kidogo. then we can mix. With the oh, it's this is what the mind
Yeah, so if you put in the model lab, minus 80. Okay. Inside, how is it constituted? The rights, it comes with the rights or the right of
you can put another one there. So you can start with 2.
So the rights are inside. How much is that one is like a governmental fund.
Yeah.
I can pay you installments, 10 installments.
So you do that for big, equipment to put in settlements?
When you see, you can see you can cover.
Up to bypass.
Don't tweak the gel at the bottom.
Yeah, it's everywhere. And you know, they break down very easily. You know, last year in December, you know, when we went for the holidays, yeah, for Christmas holidays, we came, we found the minus 80 math. You know, my samples, 20 samples out there. Cell lines that are only that are like cancer cells.
Real thing is to start
So it says that. You know, if I do that project that I told you about.
The elbow helps a lot in this.
I hope
That is why I'm saying we're supposed to have some elbow, pivot, you know. Otherwise you miss.
You can also use the loading by
See, I wish the white thing. I'm telling her what to do. So this one is now presented for, of course, many samples.
Just be right. We're gonna use it. Are we taking now?
Look at hospital setting.
I do first, second.
Research.
You can take first.
bring it, even if we use to ship one. So how much
So it takes time. It takes 6 months. You've not done it yet.
Try again. Yeah. Yeah. It's there. Check the center. Yeah. The center is
Maybe the guys that puts the samples in boys.
Basically a gel, just the same as this, because the same principle. So you cycle sequencing on the other
from
side,
this side.
and you load the sample for healing. It's just typical gel. So what happens is
But what I'm not getting is the PCR is for amplification. How do you transfer it to sequencing? Because the amplifiers will start on a real time and you will detect the fragments. When it starts, you detect which base is left because it's blocking after each one base. I go for the first one. So then there's nothing like detection, it's like amplification.
so you only do amplification.
Then
So you do direct termination on the other side. So you have your sequences of different places. So remember we have two PCRs. You do the first PCR
and you have the gel left.
based on that you do. Then the second PCR you do it forward, separate, the reverse, separate, with the dye terminators. So you have like amplicons but of different sizes.
Yes.
The dye terminators. When you bring it right now, we bring the samples to the gel, you bring the samples to the sequence.
Which means that the PCR kit would be quite different to contain terminators.
Yeah, so we have kits specific with terminators that we use for sequencing. That's the second PCR we do cycle sequence. So we'll be able to go through that.
And the PCR is like, it's one reaction PCR or it's like multiplied termination?
It's a much, that's a typical PCR reaction.
So you do it once or for each termination you redo it?
So you do so many terminations.
So many terminations, which means so many separate reactions. So many PCR.
Really?
So many runs or one run?
So you're talking about the cycles or
The runs.
The runs.
How many runs?
Just a single run.
Oh, that's it.
So this is the anode, the cathode. The same way you have a cathode on it. And that's the anode, the same way you have a anode. It's just a typical. Then your samples run in the capillaries. When they are detected here, then they, instead of seeing bands, they see here, you see sequences.
It looks like 7 capillaries.
This is 24.
24. Oh, okay.
What do you mean by 24 means?
It has like 12, 24.
That are inside the...
Isn't.
24 what?
Let me just show you. So it's a 24 cup, meaning it has 24 sequences.
They will see
They see the
okay.
sample. And we call them sequences. Yeah. Let me just show you.
You can see the sequences. So the one that suck
Oh shit. This one is where they do the sequencing. I guess the extension is doing no justice. Yeah, the box is helping. Yeah.
So the 100 months of 20.
So this is a voltage converted to current.
ratio. After 40 cycles, a ratio is still conserved because both of them are multiplied by, let's say, 40. So the ratio is still conserved. If initially they were 10 against 40, after 40 cycles they are 40 against 120. So the ratio is still conserved, but we amplified for us to be able to detect or visualize. But the ratio is conserved as long as they had the same run in the same PCR and they ran for the same time and for the same number of cycles. They started together, they ended together. So the ratio is still conserved at this point.
So can you correlate that with, say, a gel assay as opposed to a qPCR assay? Can you say that the brighter the band, the more copies you are having?
Yes.
Okay.
There's this word ladder.
Yes.
Mhm.
So the ladder is not that.
I think it's
Behind, yeah.
So the ladder is they're just basically fragments of DNA fragments of different sizes in a single tube. So they run in the same lane, then they separate differently. So you have that separation. So the other thing I wanted to tell you is when you're doing your gels, make sure you have this middle line right as possible. So that also QCs your gels. So sometimes you overstain your gels and you think you have like bright ladder, everything is bright. That means you have overstained your gel. Doesn't mean that your ladder is perfect or something. So that's another way we see our gels. Okay. Any other question?
In terms of the ladder that we're talking about, are there like ladders for RNA or DNA, or are they just the same?
I think they're just the same. They're just the same. Like they're just fragments of sequences. Yeah, so you can't have like a ladder for RNA or DNA. Just yes.
I think we have a ladder for single strand RNAs. No, New England Biolabs.
Yeah, she's been. I mean, she knows the products more than I do. I'm just a sequencing.
Oh, okay.
So I do DNA. In some lab we don't sequence RNA. We just do sequencing and but I also do the molecular work. So I can't tell you the nitty-gritties about the composition of this, but I know the basics.
That's why you need to hire me.
I see she's on that line.
Okay. Any other question? Any other concern? Yes.
Do you guys become a snake scratch or the green thing? What is it exactly?
Yeah, so we don't do master mix. We don't prepare DNTPs, magnesium, all that. We just buy master mixes. Already constituted, like the ones we use.
But you make them in South Africa?
No, we don't. We buy them from NAB.
But if you wish,
If you wish, we can also bring in the components.
you can bring you the components if you wish. So you can like get your magnesium, your DNTPs, your polymerase, Actually, some people say they prefer doing that.
You know, if you have a web page, like I can put some stats for you, I'll give you 10 out of 5. Not only 5. We have to rate you.
I'll tell them to do a rating review for the content creator. Tens only. Yeah, but
So it's actually cheaper to mix the components than to buy the master.
but then the chances of contamination
And staying 1 year in the lab trying to optimize your experiment, yet they are already optimized.
If you are doing extraction, normally in the lab, like if I introduce my setup, I have my vet. This one vet all of it to avoid some errors.
No, it's true.
Because if you use one, then another one.
Yeah,
And this is found in your house.
if you work with
Yes,
the elderly,
they want to
you will make that mistake. There's some smell, no? So you all know the gel dog? Yes.
Sometimes your experiment is so successful. You reach the last minute to break the gel.
Yeah.
You throw everything, you come back tomorrow, repeat. It's there. It's here. You can see 1, 2, 3, 4.
There are three. The first one is the ladder. I can't see it.
It's here. It's here.
Then you call this
But
one.
I can't see the ladder.
for sure.
It's here.
No, but the ladder. That's the
It's there.
So remember I told you.
You can see the bands here.
Oh, yeah.
And this is what Brian was saying that you need to
Yeah.
do to be sure that it must be bright.
The good thing is selling these items, you get to see them every day.
Yeah, actually we got it 2.
You have the
We normally got 3 or 5.
But she wrote it bad. Oh.
Sorry.
So we loaded less.
I think it's you can check in there.
I see the others appearing in blue.
Actually, we have a system that is trained to
So I think it's all about
remove the
background.
genes, but